Nothing is possible without mathematics. Everything around us is mathematics, everything around us number. A warm and pleasant good morning to one and all attending this international webinar on applications of linear programming in performance measurement. Prayer is the peace of our spirit, the stillness of our thought, the evenness of our recollection, the seeds of mediation, the rest of our cares, and the calm of our tempest. Let us begin our session by a prayer song seeking the blessings of Almighty.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं धृतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः प्रत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिस्तुतां दर्शने भवत्तव नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनाम विभेदेन जगत्क्रीडति यो यतः ओम शांति शांति शांति.
Dear participants, feedback link will be posted in the chat box at the end of the session, and it will be open only for 2 hours from the end of the session. E-schedule will be provided only on the submission of feedback form. Participants can post their queries in the chat box. Now, I request Professor R. Venkataman, Convener and Head, Department of Mathematics, D.G. Vaishnav College, to enlighten us on the webinar.
Good morning. Hope this morning will be an effective performing morning. With immense pleasure, I welcome our resource person, Dr. Ka Venkatesh from Myanmar Institute of Information Technology. I wholeheartedly welcome every participant on this live stream. I thank and so grateful to our management, the secretary, the principal, and the most enticed and dedicated faculties of PG and Research Department of Mathematics, DG Vaishnav College, and the participants for conducting this webinar series successfully. This pandemic milieu can disturb our learning process and the willingness to learn. நாங்கள் வீழ்வோம் என்று நினைத்தாயோ. Yet with all possible positive motivation, we are here and conducting this webinar program. Our eminent and experienced Professor Dr. Ka Venkatesh from Myanmar Institute of Information Technology will enlighten us with his profound knowledge. He is here with us today to render his lecture on the topic application of linear programming in performance measurement. I am sure that it will throw light for the betterment of our knowledge and enhance our skills to approach this topic in a self-confident manner. Sustainability is most important to succeed in any environment. Sustainability is vary from a person to person and an organization to organization, because the sustainability purely depends on the efficiency of a person or the efficiency of the organization. If a person or an organization is very efficient, then the performance will be very effective. So the effectiveness depends only on the efficiency, that is the performance. To analyze the effectiveness, then we have to measure the efficiency, that is nothing but the performance. More methods and models are available in practice to measure the performance, but they are parametric. From the perspective of the observer, these models are not suitable because the observer may not be part of the system or may be one-time user of the system. Then automatically the question will arise, are there any scientific ways or any scientific tools to measure the efficiency, that is the performance? The answer is yes. That is nothing but today's our webinar topic on application of linear programming in performance measurement. An extension of linear programming problem is the leading tool in performance measurement. Actually, the efficiency is the ratio between the input and output. Hope Professor Ka Venkatesh may help us to measure our performance of this webinar series. Finally, I would like to quote from Angelo: develop a passion for learning. If you do, you will never cease to grow. Thank you.
Thank you, sir. Now I request Ms. C. M. Subbalashmi, Assistant Professor, Department of Mathematics, D.G. Vaishnav College, to introduce the resource person.
Good morning to all. It's an honor for me to introduce our resource person for today, Professor Dr. Ka Venkatesh. He qualified his postgraduate in Madurai Kamaraj University and completed his Master of Philosophy in Manomaniyam Sundarnar University. And he completed his doctorate in Alagappa University on combinatorial optimization and passed his lectureship examination in 1990. Dr. Ka Venkatesh, Professor of Math and Computer Science, MIIT Myanmar, Adjunct Professor, Indian Institute of Information Technology, has 3 decades of teaching experience for MSc, MCA, MBA, Computer Science and Engineering. He served as a head of the Department of MCA and principal for Alliance School of Management, Bangalore. He has also served in industry for 4 years as CTO and head HR for software product development company iSource worldwide in India and USA, under consultancy assignment from Alliance University. He is a very active person in research, wherein he has 68 publications to his credit. He also co-authored a book on discrete mathematics published by Vikas Publishing House, 38 study materials for 19 universities in India in areas of discrete mathematics, quantitative techniques for business, linear algebra, matrices, and many more. He has also visited many countries like USA, Canada, China, and Hong Kong for professional services. He presented CDAC in China, High Performance Computing Conference in the year 2004. He has received Research Excellence Award in by Indo-American Education Summit 2016. Is in the list of top 10% of authors on social science research network by all-time downloads since 2016, ranked 15,541, whereas total number of authors were 360,000. He is a member of System Society of India, Ramanujan Mathematical Society, Indian Statistical Institute, Karnataka, and also founder secretary of Academy of Discrete Mathematics and Applications. I hand over the session to our resource person. Thank you.
Thank you, ma'am. I sincerely thank the organizers for sharing my experience and my view of mathematics in other fields. So today's talk is going to be, if you understood mathematics, a small deviation I'll do so that it is easy to apply in day-to-day life. I believe I grown because of this philosophy, believing I can see mathematics everywhere. Once I see the notations like sigma or whatever it is, mathematical notations, I feel it is my subject. I did not feel it is from other discipline. That is one way I learned many subjects. Still I'm learning. This is last 3 years I'm into data envelopment analysis due to some reasons to measure the performance in the banking domain. So my journey started from that. Then I started looking at data envelopment analysis as a tool. We were successful. Then we applied in cloud service providers, ranking of cloud service providers. There also we did some work. It's going on. Once you understood, you can measure anybody's performance. Professor Venkataraman very clearly said, performance is the order of the day. So you are measured against performance. So there are slight different terminologies one has to understand. If you are in the medical field, you may know better. There is a slight difference between efficiency and efficacy. So here we talk about efficiency. The scenarios you have to say mathematically, we have to do a lot of limitations. We have to assume certain things. Any mathematical model needs certain assumptions and limitations also there. If you look at performance or efficiency as per the definitions, output by input is the efficiency. Mathematicians or engineering principles says that the efficiency cannot exceed 100% or between 0 and 1. But the real life scenario, if the profit is, I say this manner, it is not right. So I have to do certain variations also. The efficiency not bounded by and 0 and 1, this is also supposed to be considered. So this all how we are going through LPP. That is what the today's topic. So a slightly different way. Now I'm going to talk in slightly how it is related to geometry. How many of us really looked into the geometry behind the operational research? That is very important concept to understand. From operation research to functional analysis, operator theory, everything can be connected. Therefore, a couple of minutes or probably 5 minutes, I'll talk on certain aspects of geometry, which is needed, why it is needed, how it is related to performance measurement. Those who are studying MBA or those who are specialized in finance, they do something called as frontier analysis. That is what we are going to use here also as a frontier, which is we call it as efficient frontier, how to arrive efficient frontier. That is the first part. So that is +2 level mathematics is sufficient to arrive that part. Then beyond that, if you want to analyze, really enjoy mathematics, then we require the geometry. So my flow would be like that, little bit of geometry, then I'll talk about LPP. Subsequently, I'll say about how to solve LPP using one of the MS Office tool called as Excel. Then we'll go towards how to model the performance measurement as an LPP. That is called as data envelopment analysis. So the data envelopment analysis, it has 3 words. Data, yes, obviously we know what is a data. envelopment, since we are from, most of us from mathematics or economics people, most of us we study game theory, because game theory, we think game theory is something nice and all those things, fine, but it is the strategy. So how to capture one's market by different strategies. That's how every promotional material comes into the market to identify. There we talked about envelopment. The real meaning of envelopment is it covers my entire data. That's what we are going to look at here also. That is what frontier analysis. So then analysis, obviously we'll name what is analysis. So this is the outline of my talk. Now I'll go with my presentation. Just a second, I'll share my screen now. Are you able to see my? You're able to see my screen now. I'll go with presentation. So the title is, so far we talked about that, applications of LPP in performance measurement. So this is already said what we are going to talk about this, and one case study I'll do that. Uh, this is what important concept. We know convex region. So any 2 points, the line segment connecting between any 2 points lies entirely in that region. We call it as convex region. So beyond convex region, we look at this part. If you look at that way, you draw two lines from the origin in the XY coordinates. If you rotate it, obviously it's going to form a cone. So here we talk about little more about convexity, also supposed to be required in the optimization concept. Therefore, we talk about convex cone. So from linear algebra, because linear stands for the linear functional, hence this is also required. Convex cone is a subset of vector space over an ordered field that is closed under linear combination with positive coefficients. So this is what is the order field. We are familiar with partially ordered set. The fields happens to be partial order along with the vector space. That is what we call it as order field. Then the question is every cone is a convex one? So looks like, but not. If you take to raise, like I said, half raise, if you take, it may not be a convex cone forms like that. So for that, you should know what is cone or a linear cone. Take a x from that cone and alpha from the field. Alpha x supposed to be in the cone. Then we call it as a linear cone or a cone. Then when a cone is said to be convex, yes, this property is known to us. So take two scalars and 2 points in the cone and alpha x plus beta y this into C. Then we say convex cone. So this is other way of defining us. This interestingly, this is that C plus C is a subset of C. Then also we can call it as convex cone. Variety of definition one can have it. So this is required. So this part is sufficient. So now this question is you have to just think over it. Can we say convex cone is a special case of linear cone? So the linear cone, we know, you take a point x from the cone and a scalar from the field, then you'll say alpha x is there. The same thing can be used to prove this part also. If I write alpha x as alpha by 2 times x plus alpha by 2 times x, which is nothing but alpha x, therefore it's a special case of a linear cone. So every convex cone is a special case of linear cone. So that is very important. So then is every cone is convex? As I said, it is no. What you can do is you take the r square field, then one of the coordinate is greater than 0, other one is 0. Take the union of this. So obviously you'll get it is cone, but not convex. So then we have to talk about affine convex. So the affine transformation is a special kind of linear transformation. There is a slight loosely talking. There is a confusion over this. Every affine transformation is linear. There are certain examples says no, but mostly it is yes. So the affine transformation, the meaning of affine transformation is it's preserves certain properties, like convexity is preserved. We need convexity, then similarity is preserved. A transformation which preserves this kind of things is called as affine transformation. You apply affine transformation on a cone in order to obtain sorry, excuse me, affine convex cone. You take affine transformation as f plus c is going to be c, need not be a cone, but it satisfies convexity, therefore it is required. So if you take affine cone affine transformation 0 plus c, is going to be different thing. So you have to look at that kind of things. Convexity should not be lost. Under that assumption only we are talking about this. So the hyperplane is known to as f of x equal to c, where f is a linear function. So we have this linear function as different linear transformation. So I meant that linear algebra term linear. So we know f of x equal to c. Then we can define open half space or half plane as well as closed. So that is f of x either greater than or equal to 0 or less than or equal to 0. Strictly less than we call it as open. So this all properties are known to us. This is very interesting. This is what, if you look at this now, any one of you can, before we move to linear programming, you just imagine how this transforms into linear programming models. Once you understand that, then moving around is much easier. So then the relationship between half spaces are affine convex cones. That is very clear things. So still we have to talk about polyhedral cones. So this is very interesting thing. Cone is a polyhedral if the conic combination of finitely many vectors, linear combination of vectors, if you are able to express in terms of that, we'll get that. The other way of defining is it is the intersection of finite number of half spaces with 0 as its boundary. So that is also possible. So still you can talk about a cone is a polyhedral if there exists a matrix A such that set of all x in R power n, Ax is greater than or equal to 0. So many ways. Now the relationship is coming. A cone is polyhedral if it is a solution of system of homogeneous linear inequalities. So this linear inequality you can see in the matrix as every row so passes through the origin. That is going to give us the real geometry behind LPP. So when we talk about normally when we go the primal problem, then duality is known to us, how to write dual. So can we define cone also the same way? Yes, it is possible. So take as cone, not necessarily convex in the linear space. The dual can be defined whenever there is another point from the vector space, one point from the cone, the inner product space supposed to be, inner product value supposed to be non-negative, then we can talk about that. Or you can say in other ways, it's positive. The linear functional operates on W is positive. That is also possible. So as I put this, supposed to have done the other way, when all this if it is vector space is finite dimensional, obviously these two are going to be equal. So now as a mathematical people, we are supposed to think it of a Rees representation theorem either from the Hilbert space way or the other way also, topological way also. You can think it of how it is related to this two. So this is very important. Here I have to speak something else also. One thing over it, I'll give the answer. What we talk about that is it's also preserves certain things. We talk about that the functionality, the operators we'll talk about, and the map will take. That is one side of things. The other side, if you look at that, we might come across something called as Minkowski's sum. So what is Minkowski's sum? It is nothing but addition of two vectors. A nice way, if you do that, from that we can get convex hull of Minkowski's sum. That is really needed in today's world. Convex hull of Minkowski's sum, a plus b. We know that what is the vector? So you have a point-wise addition. You can do. We'll get the vector nicely. We'll get. This is what used in the autonomous car also to detect the collision. 3D solid formation modeling everywhere. These properties are utilized. So when we align as an autonomous institution, I normally suggest that can we have certain percentage application from the geometry or the pure mathematics to application side, so that interest can be created, and also we'll also get motivated to do more this kind of application. So this is one. Then here this is the part important results. The convex cone, that is not entire whole space, obviously it should contained in one of the closed half spaces in that space. So this is a special case of Farkas lemma. So when the solution exists, if you look at that, the duality, what we talk about in the operational research as duality theorems, so this will come into picture. So if you view this as a geometrically, there is a hyperplane. The hyperplane is separated by a normal plane between the convex cone and other things. That's what we talk about here. The ATY equal to B, BTY is less than 0. So you have to just visualize this results. That is easy. How it is going to relate in performance management is because LPP, there we are not going to say efficiency in a different way. So we need this part. So this is the basic geometry what we required. Now LPP is known to us. So it is a one single objective function, a set of constraints and non-negative restrictions supposed to be there. There is a typo error. I'm sorry about that. It should be non-negative restriction. So what is that single objective function and set of constraints? Now we have seen that set of constraints could be either half space or the open space, half open space, inequalities, or anything is possible. Then we can talk about it as nothing but polyhedral only. It's a matrix form, AX either less than or equal to or greater than or equal to. So everything lies in that. So our operation is going to be in the convex cone rather than the hyperplane and other things. We say hyperplane again, it's forms of convex cone only. So linear combination of all possible things. So this is, once we know this part, how we are going to solve LPP. There are variety of methods. One is we talk about the simplex method, then we talk about artificial variable techniques, then we have revised simplex method, then dual simplex method. After that, beyond that, dual simplex method. Beyond that, something very important in application called as sensitivity analysis. Please, I suggest all of us, whenever you get an opportunity to teach or whenever you learn, we should know what is the use of duality. Duality plays a major role and sensitivity analysis plays important application. So here also we talk about duality in performance measurement. So that is required. Therefore, I'm said all this are important. Now, data element analysis is an extension of LPP to study the relative performance of any organizations and individuals. So DA not only helps to identify efficient ones as well as inefficient ones according to the context what we consider. So now the moment you identified a certain students are, I'll take a classroom environment, being a teacher, that would be a better example. That could be top performer, there are some poor performers, how we can change them. So we know they are not doing well, how to do with the help of the efficient ones, how to benchmark, what modification we can do. So we do, but when you do as a model, it will be done. If you look at that, why I talked about this context is the first paper before DEA came into, the word came into existence, done in agricultural industry in US. Later part, it is applied in a program fellow performance. So therefore, it is very important to understand the history that helps us. So we can do, that's what the last point talking about, how to make the inefficient one, improving their performance. Okay, so the history started from production environment, 1957, Farrell's efficiency. So production management had started. This little later, so we are much earlier to that. You can see Debru's coefficients of resource utilization from economics, 1951. The same year, the Nobel laureate's paper talks about that. That got a Nobel Prize for him a later part. That is called as optimum allocations of resources. So this all piece and parcels in somewhere I'm able to do certain extent collectively put together. Then I said this is applied. There's first applications came in agriculture without the name DEA. This Rhodes, one of the first DEA model is called as CCR model, Charles Cooper and Rhodes. So Rhodes is also part of that. He used in education, 2012 health sector, 2010 in the university, how to measure which university is better, the given scenario. So that is also done. In India, we have a lot of ranking agency doing some kind of work. Unfortunately, none of our methods are following. The DA is not adopted. Why can't we try out when we are ranking at our institutions in the same environment? We can find out which institute is better, whether it is, how far it is coincides with the existing model. The NIRF model also one can think it of whether it is right or not. So it's a debatable question, but as a paper, yes, it is possible. Interestingly, the very first book, as per my understanding, written by one K. Ramanathan, but he settled down in another country. Then subsequently, many books came into existence. Ali Ibrahim Edmund G is in US, his books, and he also has a software called as PIM. So all those things, and economics people work more than mathematical people. So this is the basics of DEA. To model things, what we do is the organization or individuals are required must be homogeneous. So this is meaning is, can I compare the colleges affiliated to University of Madras or across the universities or across the country? You have to decide that should be homogeneous. So that part is clear, then it is easy. We are going to measure a relative performance. So this organizations normally in the DA literature it is called as decision making units. So this is a terminology you should know. Then we have to find the efficient frontier. So this efficient frontier, some line we'll talk about how this frontier line is coming into the picture. Now to relate to the geometry, whatever I spoke, the frontier with the x-axis or the horizontal axis, whatever you take, it forms a cone with vertex at the origin. Therefore, we talked about the geometry. In DA literature, we call it as production possibility set. So just I'll give you with certain amount of input, I can produce certain amount of output. So I collect all such pairs. That is called as production possibility set. That is nothing but the convex cone comes into picture. So now that is the relationship between the geometry and this. So we can talk about this definitions little later also. Now, how to find the efficient frontier with respect to this example? I've taken some stores and number of employees and the sales per stores is given. Just ratio I've taken as per this. So sales per employee. So we are able to see a B is doing well. Then if you draw the scatter plot, you'll get nice picture between this part. So then the efficient frontier, how you are going to do is every point store 2,1 is a point, 3,3 is a point. So the scatter plot is drawn. Later part, to draw the efficient frontier, you assume that every point to the origin, find the slope, which has highest slope, draw the line. That's how the B is sitting on the frontier. All others are not on the frontier. Interestingly, look at this model. Nothing goes beyond the line. Everything is below this line. Therefore, this gives an idea. Frontier is slightly different from regression line. Regression line also give me a set of data X and Y. I can find a prediction. I can fit a line. Yes, frontier is not the regression line. So this is one more. This also, that's what I talked about. So the line corresponding to the highest slope is the frontier. So you can find out it. So now this point I did not talk with respect to the picture. So every data points are below the line. Therefore, it is called as envelope. So is the frontier as a regression line? Answer is no, because when you draw the regression line, the data points not necessarily either below or above or on the line. It may be anywhere. So based on central tendency, obviously it looks in a different manner. Between the points it will go. So look at that way. So what is the difference between frontier and regression? Regression lines, as I said on this. So in regression analysis or in the finance, sometimes we talk about that models. If beta is greater than 3, it's excellent. It is 3, it is doing the expected things, and below unsatisfactory. So that same kind of things here also we can talk about that. So frontier line identifies the best one. That is what important. It towards benchmarking. So how to improve my store's efficiency in compared to the best one? And that is also to identify that we call it as peers. Then we use the linear combination of peers to make sure that the inefficient ones also does its job better than the earlier time. So that's what we are going to talk about that. So this is the foundation. So in our example, B is the efficient one. Others are inefficient with respect to B, because B has the highest slope and the frontier line sits are there, therefore it is. So to obtain the efficiency score, this is a formula we use. Always it lies between 0 and 1. Under this assumption, the basic models. If it is beyond 1, are there any model? Yes, we have. That is called a super efficiency model. There are 32 DEA models are available. In this session, I'll be talking about very minimal, not at least 2 models I'll try to cover. We'll see how best we can do that. So you can see the regression line and the efficient frontier, how it differs. So if you take the other efficiency scores are like this. So can we improve? Suppose you look at the point A. A was between 2 and 1. What is the meaning of improving the efficiency? Can I bring this data point A to the frontier? Which are the closer? Either I can make to 1, 1 or 2, 2. If I do it, it will comes to B. So how can we improve that? So that is the other way. Look at that. The definition is a ratio. If the denominator is 1, I maximize my efficiency. That is also one of the ways we can. Sorry. Okay. So this, if you translate to the place or the data points, that is number of employees. If I reduce it, that is one way. Other is increase the sales per employee. So both are possible. So which is required is linear way, linear combination of this. Can we do that? That is what in the next slide I'll be talking about. This is the best example. This sometimes we call it as unit invariant. So if you look at the general market, what when you buy a vehicle, they will say a motorcycle or a car, they say per liter you'll get X mileage. Is it true? Really, it is not. So then what is that? That's what we are talking about. You take the ratio always lies between 0 and 1. So the engineering principle, but per liter is mentioned. So therefore you divide, the ratio is not going to change. Therefore, this kind of measure should be considered. This is an example I quoted. So when you take a measure, that unit is also important. You should not take different things. So especially the banking, we have when the parameters are they give in a different form and we have the data, can I consider it or not? So that is how to study the collect the input and output is totally different thing. There are 16 papers available how to select input and output. That is also I'll be talking about a little bit, but not in detail. What you assume, what are the possible inputs and output? Take the correlation. From the correlation I can take it. That is one approach. The other approach what says that instead of finding the weights, can I do the PCA, principal component analysis? Instead of having in the linear space, can I move to the eigenspace? Then eigenspace, can I choose the input and output? Yes, possible. That gives better, but not all models. So you have to see the models, then you have to apply that. So that is another part. So this is a one more example. I'll just want to show the frontier. Mail looks like this also. Now look at this. The frontier is E and D are here. A is in between. Now if I want to make A as efficient one, what I have to do is I have to choose A. These are the with respect to E and D. This is the part. So as a linear combination of this, I do that. I can bring up this side. That is possible. And look at this. This is not a straight line always. So therefore, one is looks like piecewise linear function. Then approximations I can do. So this is the again. If you look at the other concept called as in mathematics, we have knot theory. From knot theory, what I can do is this kind of things. I'm able to find out, can I fit a multiple adaptive spline? So that is also possible to approximate it, but it won't give because all those regression lines are parametric ones. So we'll talk about that parametric ones little later. So here, the moment Professor Venkataraman said it is non-parametric, the meaning is slightly different from mathematical parametric one. Mathematical way, if you know parametric ones, give me the parameters, I can generate entire spectrum. So entire gamut, I can generate it. Here, the parametric is not. The inputs and outputs are decision of the model maker. If, for example, the best example I can quote is this COVID time. I'll quote this example. Unfortunately, one of us got this. Suppose not happen. So which hospital I have to take? So what are the input and output? You measure something, you will create it, you do that. As a medical practitioner, I may do something else. As a governmental agencies, my input and output differs. In this concept, therefore, it is non-parametric one. So that's how we have to think it of, not mathematical parametric way. So the input and outputs are, there are two ways. One is the production approach, other one is the cost approach. So the production approach, we are talking about the production cost, production values, the raw material values and other things. The cost is cost factor involved. So that is how you have to look at. So when you go this side, then obviously we come to know there are certain models called as Cobb-Douglas model. The Cobb-Douglas model is a very elementary function. Probably we might have studied in the function when we started, we might have studied that way. Some function y equal to a into beta power alpha I, beta I power alpha I. So take logarithm, then make into arithmetic model. It's a multiplication model. That is a Cobb-Douglas model from the in economics time or the economics way or the mathematical way you can view that. So when you convert this side using logarithmic, that creates a nice quadratic programming way. So that is also possible with. So that is when we go inside, we'll get a lot of better ideas. Having a strong background in mathematics, we can understand better and better. We can do a good job. So with this definition, how this can be converted as a DEA. So this is what I'm considering only one organization called as small a. The efficiency is given. What is the meaning of that? YJA, that is the output produced is YJ for the organization A. XIA stands for the input supplied in order to produce output YJ. So with respect to that, what is this VJIA? And this is the weights we supposed to identify. So this is the place we need some kind of methodology, mathematical modeling to know that. Also, it is bounded by both sides. So 0 and 1, because of engineering principle, always efficiency lies between this. So in such cases, we have to talk about entropy and other things. What is we are going to do that? So this whatever I'm going to talk is with respect to maximization. So this efficiency, if you want to do maximization, what is that? This ratio is supposed to be maximum value. The one way is the denominator is supposed to be 1. So strictly positive, that is virtual multipliers, we call it as, that is always we put the decision variables in the operation research, or LPP, we call it as non-negative restriction, that we put that all efficiency must be 0 and 1. So making denominator equal to 1, certainly we can make this is better. So now with this, can we write a model? So before going to this model, we need certain basic definition in the context of DEA. Already I talked about production possibility set. It is nothing but the affine cone what we create. That is the frontier line and the horizontal axis. In between this, all data points is going to lie in this region. That is a affine cone we have. With that, how we are going to derive this? So that is nothing but production possibility set, I said. So mathematically, how to define that? So certain input is known. Our system is supposed to produce an output O. So the set of all such pairs is called as production possibility set. So once you have production possibility set, so we should know what is input efficiency as well as output efficiency. So our idea is, I know I have this much input and which can produce certain amount of output. Can I reduce the input to produce the same amount of output? If it is possible, that is what called as input efficiency. Now the other way, we can talk about the output efficiency also. So how can you talk about output efficiency? So input is fixed, output is certain amount we expected to produce. Can I produce more than that? So that is what called as Parallel's output efficiency. So mathematically we can talk about FOE because that's all notations for convenient, one can define anyway. So now when you have this, so how to identify this K and RL? That is the question now. So if you are saying this is possible, so that creates two more models. What I'm doing here, the first one is input efficiency. I want to reduce the output for a fixed amount of output. That is called as input oriented model. Now the same way, you fix the input in, can I maximize my output? That is called as output oriented model. So in the LPP, we are going to have these two kinds. Now don't confuse with this. Our objective function in LPP, either optimization like maximize or minimize, not that we are talking about here. That is also possible. There we'll talk about in terms of duality, not with respect to this. So is it possible? That's what we are going to talk. So in addition to that, now you have many pairs. Which is the efficient one? You can say that is one is better. One is better in the sense that the input should be less, output should be maximum than the other one. Then we say such pair is dominating. Among all such dominating pair, which is the maximal one, that is going to become as efficient one. In other words, a pair I comma O is efficient. There exists no such pair which dominates this one. So that's how we define mathematical way. So we have that as a pair IO is efficient. The production in the production possibility set, there are no such pairs dominates this one. So we can talk about this also. Then we have variety of efficiency. I just listed out the basic only. whatever we talked about, it is called as technical efficiency. Now the input vector, whatever you take and replace by cost vector, it is called as cost efficiency. The ratio between cost efficiency and technical efficiency is called as allocative efficiency. Then we have something called as free disposability hull. Now again we have to go back to the hull concept of convexity. All intersection of the convex regions you take, that will get the minimal smallest set. That set is called as convex hull. So here, are we going to do that part? No, if you translate in a slightly different way, the input is available. Lot of input is available. It is abundant amount of input is available. Then can I produce the expected things? Yes, possible. Can I minimize that? I have many. Can I utilize all? You are allowed to use, but can you reduce it? If you are able to do that, you are having more input, still you are not using the entire input. The same way, I've expected to produce this the output, but I'm producing more. So obviously that kind of environment, we call it as free disposability hull. So convexity is, again, I don't want to talk about that. We know that instead of x and y, it's an order pair. If you just, I can replace this I and O with the Euclidean plane r square, obviously I'll get this convexity. So that is. So the other part is return to scale is very important. If we come from the economics, unit reduction, how much it is going to proportionally, how much it is going to increase. So that elasticity of scales, one can talk from the economics, but the mathematics, we talk in a slightly different way. This production possibility set is given for any linear combination. Can we have that lambda? Depending on the lambda, any scalar linear combination obviously going to be in that production possibility set. That's the reason I talked about convex and polyhedral. So it's a polyhedra. So obviously alpha times anything you take, that is supposed to be in that polyhedra only. Hence it is. So mathematically you can view this way. Now having this, by depending on the lambda, we have to define one as constant return scale, variable return scale, increasing return scale. All those things are possible. So if lambda is greater than 0, we'll get constant return scale. Then decreasing scale, if it is lies between 0 and 1, and if it is greater than 1, increasing return scale. So this all possible when you view the frontier, how it looks like. So CRS at straight line, VRS, look at this, the frontier differ this. At time, it's a very simplest way when we talk about that average of functions. When we talk about that, then if the slope is constant, then we talk about all such things. The same way here, the slope is constant. Here, this is the different way. The slopes are varying it. So we get frontiers different way. So this is variable. Then the next is FDL looks like a staircase function. IRS, at some point it is going that it is a slightly different from BRS and other things. So one can think of this with examples when you have, you can, which you're supposed to use the RTS from the domain expertise or observing the pattern, one has to discuss and identify that. So we have basically input oriented, output oriented. There are variety of return scales we have, but broadly it can be classified into two. One is constant return scale, other one is variable return scale. So using this, we'll get input oriented CRS, output oriented CRS, input oriented VRS, output oriented VRS. So you have this kind of models. So once you have this model, which model is suitable to us? So that's what you decide based on the domain what you're going to do. So this is just a small list CCR model. That is what we are going to talk about. Primal and dual, both are same. Then CCR model and BCC model, what we are going to do, that is a small modification. The convexity is also assumed inside. The earlier CCR model, convexity is not assumed. If I add the convexity constraint to inside, I'll get the BCC model. CCR stands for cranes and codes, Charles and cranes, then roads. Banker happens to be an Indian, Rajiv Banker. Then the other two are the same people. Little later, it has come into existence. The super efficiency model is where we can allow this beyond that. So DEA model with weight restriction, how can we do cross efficiency models? So the benchmarking in DEA is based on efficiency scores. One can rank who is doing better. We can make sure, keep that as a benchmark, how to improve. Then the window analysis is nothing but the time series data is available. that is called as Malcolm's index for a particular firm or different things you take. Every term the values are varying it. How we can do that? So Malcolm's index is one of the DEA Windows model. The ordinal and cardinal data also can be addressed. So there are some, now the question may be asked, suppose I don't have an output, can I measure it only input, but it does some work? I want to know whether yes or no. Yes, possible. We can do in with output, without output, with no input, only output. Everything is possible. Beyond that, this is once again it goes towards multi-criteria decision-making models. The moment we talk about multi-criteria decision making, that also classifies into two based on attributes and other things. So in that, mostly the earlier balanced scorecard method, analytical hierarchy processing, analytic network processing. So many models we have. All those are, every model is applicable. One can compare. So there are popular models other than that. TOPS is Electrive 1, 2, 3, then Post 3, then after that Vigor. So many models, multi-criteria, but this is one of the very close to mathematics. So therefore, I'm working into this. So this is having given that. So now we have everything in general way, ratio between weighted outputs and weighted inputs. So based on this definition, I'm defining or maximizing this. So that this. Now, we never come across objective function or constraints in a rational form. So how we can do that? So our objective is to maximize. Therefore, that's what I written earlier. How we can convert the scenario as a LPP. The denominator I'll make as a constraint which is equal to 1. That is constraint 1. The remaining constraints are formed from this place. Now this ratio is there. Move the ratio, the denominator portion to the right hand side. Bring it to the left hand side. So now this constraint changed as u sigma some ui yij's, and this will be minus of this less than or equal to 0. Already we given this weights are. So now it's just an LPP. Now the problem is LPP solving by any tool is okay. Now here, then there is nothing interesting why I'm going to solve only one score, but I consider my entire branches or entire universities in this country. So in such case, we have close to 700 universities, sorry, 890 something now. So that universities we have, how to know who is doing better, who is the second position and all those things. Therefore, number of LPP formed with this model is equal to number of decision making units considered, number of organization considered. So that is one important part. So I have to say some relationship between also. Now we'll convert this one. That's what I said. The denominator I made it as equal to 1. So brought it this way. So it's a standard LPP. So one small example, then before going to the other models. So some chain of restaurant, performance of every branch. So how to do this one. So when you want to do this way, outputs are available, inputs are available. When you frame it, we'll get 3 LPP corresponding to this. Because DMU1 is good, under that assumption you study the performance, then DMU with respect to DM2, we'll study the performance. So we have to do slightly this way. So we'll get 3 LPP. When you solve this, are we going to get with respect to here one efficiency score with respect to DMU1, DMU2, DM3. Whenever we solve an LPP, we're supposed to study about the slack. In general, mathematically, what we do is slacks are present. We'll just say, or beyond that, we say some unused resources are available. We won't bother about which resources, where it is not. That is a place I also started picking up after some time, not during my earlier years of teaching. Sensitivity analysis helps us to identify which resources. Then there are two things. One is called the shadow prices, reduced cost, how it works. All those things can be played into that. So the slack is important. Because slack, only we are doing slack. Okay, I can do with LPP. Why should I do in the EA model? Then who are my peer group? In the sense that whom I have to refer to improve my efficiency. Is it going to be one person or two DMUs? Depending on the frontier picture or from the LPP scores, we can find out. But when you have more than 100 DMUs or 800 universities we have, it is very tedious to find out, visualize that. So the best way is, can I my software or can my solver give that peers whom I should refer? Yes, possible. So that is all put together we'll get. So this is later I'll come back to this part so that both tools can go hand in hand. So those who are familiar with solver, well and good. Please utilize solver as well as whenever time permits, or take one session or two sessions for the students also to use solvers to solve LPP. One way it is easy. They can verify the simplex method answer is correct or not. They can verify. Other side, they are also will have a familiarity. So now with DMUs, when we say in the LPP, we have solution exist, solution not exist, infeasible solution, unbounded, so many things we have. But when you go for DEA, when there are certain contexts may come, how do you do that? So that is different models we have to assume. But mostly when we talk about DEA or DEA is concerned, its solution exists. That's the reason I put this way. A DMU is efficient in the context of CCR, the basic model. The value, maximum value is supposed to be 1, and there exists at least one optimal solution for the non-negative vectors U and V. Others are inefficient. So the duality, you know how to write. So here, you look at this, there is no convexity constraints assumed. So dual feasibility, the same way we talk about. Now the basic DA is BCC, that is what I said. The new constraint convexity, if you add, will get the BCC model. Once we model it, it's easy to solve. Okay, now we have the tool. This tool, I'll go through it. So what is the package? R, probably nowadays R is much popular. Every time, every week, at least one faculty development program or one workshop is happening in R. So you can use R. In Excel also we can use solver. There are certain frontier tools available, but everything is it involves cost. But R is an open source, it's freely available. We can do any kind of work. Those who are in data mining or artificial neural network or analytics, say a name, everything is available. The two ways of learning are, one is there is a perception among ourselves. If you are good at programming, we can use R, not necessary. So this is all the code I'm going to use to study DEA. One line. Uh, why R is popular than the other MATLAB and other things? Because MATLAB is all, it's an algorithm based, and no one knows what is an algorithm. It's a black box. We don't know what happens inside. Normalization it does and throws some output. There is no mechanism to verify whether it is good or bad. Whereas in R, all function based. So when it is function based, you are the person writing function, or you are calling the function. The function what is does, everybody can see it. So obviously R is much popular because of that. The only one place MATLAB scores even today better is because of the graphics facilities available. The graphs are really good. Of course, there is another tool called for graphs called as Origin Pro, number one in terms of graphs and other things. But compared to this is better. So I'll show some examples on that. So this is to write the things, so peers and all those things possible. Still we have, I said the weight restriction. So as in this problem, when we solve LPP, also we have unrestricted variables. So here unrestricted weight facilities can be resolved with weight restriction. It's possible. So this is the place the managerial inputs or economic coefficients, economic variables, microeconomic variables can be added into the model, and we can do. So this also can be integrated with other models also. A lot of papers available, DEA with AHP and other things. You can start looking at, you will get a better idea. So this corresponding model, how it looks like that. So there's a place managerial coefficients can be added. I said so alpha, beta, A, B, depending on the scenario, one can talk about this part also. Now, the cross efficiency is another important thing. One has to look at that. Cross efficiency allows effective discriminations between the performance among the people. Who is really doing well, who is better, best, and other things. You can do that part. So when you the score is slightly different from the CCR model. So the score of DMU represents how well unit is performing with respect to the optimal weights of another DMU, which is missing in the CCR model. So when you want to study the best one is cross efficiency is better one than the other models. So here both. One is aggressive model, benevolent model. Both models are, you can talk about that. So once you understood one model, then which one I have to use it? So you have so many models depending on the data availability and depending on the microeconomic variable you are considering it. Decide this is what going to affect my system. See, there are certain things in India. Still, you have to develop certain areas. Industry specific variables comes into picture, so which may not come from the data. There will be an index, we have to pull it out from the industry, from the industrial vertical. That should be put as an input. So when you want to do that, so obviously I said domain expertise is required. Best is join with other person from economics or finance domain. As a mathematicians, you can do a good job with respect to this thing. So now we have to look at this case study. I'll go with this case study. So I taken this is our own work. So therefore I'm putting this in this place. Now banking is concerned. How do you know which bank is doing well? And there are two important things. This data set is available. Number one, in RBI website, there is something called as ST statistical table related to banking in India, STRBI. That gives a lot of tables. If you go, it is really, as per my knowledge, there are 27 tables are available. Beyond that, I've not looked into it. Every data is available. Nobody can say I don't know this how the bank is performing. So table one talks about something. Table two talks about assets and liability. Table three talks about this. So from that, what parameters you require. Also, this model, why I'm talking about banking industry is important is there is a report. That report says to study the performance of bank, DEA Stochastic Frontier can be used. This appeared somewhere in 2014 or 15. Uh, then subsequently many papers. Apart from us, there is somebody from IIT Roorkee also working on this banking and from mathematics department. So that's all I have to say. Now, money at call and short notice, advances in investment in India, outputs, this are we taken. So there is two important things. One is business per employee, other one is um, profit per employee. So why you not consider that? That's what I said. Now, as a banker, bank management, my lookout is different. As an investor, my lookout is different. So I have to choose my input and output. So sample input and output. So 27 DMUs we are considered here. So this 27 public sector banks no longer available. Now it is 12. So we have to talk about that the separate way. Now you have this. What we are going to do? Okay, that is, we'll talk about this case study. So window analysis, I said there is one more I'll say. This is the slides has been reverse ordered has become. So this is the data I've taken it. So this values are in lakhs or whatever it is. Look at this. There are certain places I made zero. Money at call and short notice. Why zero? There was no value. I just replaced zero, the meaning after discussion with the functional expert. So bankers advised me take zero, not median or mean. Those who are going with data analysis principle, there are two ways of handling machine data. One will they say remove those columns or record. You can do that. That is one way. We lose out certain things. The best is median or mean or median. Somebody will advise you put median, then solve it. That is not here required. Then you may ask, suppose these values are negative, can we handle it? Yes, different models we have to deploy it. So that is, if you are the other way, you can look at that negative models are available. We have done in the classroom exercise also. Take the maximum value, add this to, so the negative value will become positive, then normalize it, then remove the final value. That is also can be done. So it is up to us. But when you are doing that way, you have to write the theorem precisely. It is going to give us optimal solution. That is important. Still, that is open. One of the particular GNU model, duality is still open problem. So we have to, we address 25%. Still, we are having a lot of issues. That's the reason I went towards the convexity and cone. So we may address it. So the result is like this, the number ones and all those things. Now I'll stop sharing this one. Then I'll come back to the slides. I've just opened the R software. It's because the font size is small. So just I'm going to do some kind of things. Or this is I make it as font size of 14. Okay, so that is now the visibility is better. So now there are various steps. I'm going to use it very simple way. If I say the number one is I have to call my data. Data I normally store in CSV file. So D, I'm calling my data file. I'm going to call this the naming ceremony D equal to read.csv file.choose. There are a variety of ways to call a file, but I use this one so that wherever I stored, I can see that I stored in webinar file book one. Yes. Now I called something, whether really it is the same file I called in. To find out that, I can put head the file name what I given as D. I don't want the entire record, so I want just only 2 rows of that one. So I can put that. I'll get so first alphabet and so these are the things are available. Why do I require this part? Is when I want to utilize the column names, the spelling as well as the whether uppercase or lowercase is very important in R, or is a case sensitive one. So now I want to see whether it really represents my 27 banks. I want to see that. So dimension I put that. So 27 and 7 I'm able to see that. So 27 and 7 columns, CH, MCH, II, advances, interest income, so profit per business per employee. So we have this one. Now I have to group something as input, something as output, then what package I have to use it. So now if I just put summary for your convenience, I'm writing it. It is not needed for our study. Just to save the power of R, it gives my all statistics, descriptive statistics is there. What is minimum, what is maximum, what is mean, median, first quartile, second quartile, everything is available. So this is the way power of R. So one can think it of to use it. Now I want input and output. So the input, normally as a mathematician, input always we take independent variables as X. So therefore I'm calling it as X. I'm going to define this input, not one column. It's going to be more than one column. I'm defining as a matrix. Therefore, the name given as X matrix. So this is because this data is column. Therefore, I'm going to use C bind, column bind. What are the values? D. The column heads are. Let me see what I'm having here. CH. So input CH D. Then I'll take MCS. D dollar, then II. So D dollar, advances in India and abroad. That's what I put ADV. So these are my inputs. So I have inputs are like this. So I got my input. Suppose you want to verify whether it can consisting of the same number of records, you can verify that. Always it's good. Sometimes unequal may take that. You should not do that one. So 27 and 4 columns I taken 27. Similarly, I can define YMAT. So C bind. So D dollar. D is that data name, data file name is D I given to. Otherwise, I have to type the full big name. So I put like this. So I left out this only 2 I left out. So IIC. Not necessarily you have to take everything. It is what is needed for you. You choose as input and output DPE. That's all I did. So now I have output also. Dimension of output I can see. Y mat. It's going to give me 27 and 2. And that. Now we have to decide what kind of model, because I said we are going to use the basic model CCR, input orientation, and RTS. I'm going to take constant return scale. Okay, there is another nice thing is whether it's a tribal or dual with respect to CCR model, only constant return scale. When you want to go for variable return scale, at least you have to apply DCC model or the super efficiency model or the cross efficiency. A little beyond that, there is something called as X efficiency. So many things. That's what I put dot dot. So many things we have. We can go one by one. What model you are interested? Why you have to choose that model? That is another study we have to talk about that. So now I have to apply DEA. So the naming convention always I give which model we applied. We should know. Therefore, I define like this. I'm using DEA model with constant and scale and input oriented. So I'll go like this. The function is nothing but DEA. So I'm applying DEA. So I want this only. So DA I did. So using this, what are between what x and y, so x mat and y mat. So written scale, I wanted CRS. Then orientation. So my R has certain issues. Sometimes the orientation is default is input. Sometimes it won't take. Otherwise, if you download the new version, it works precisely. Okay. So now a DEA function is not found. Why it is not found is just I know the code for doing this DEA. This function exists in a particular package called as benchmarking. So to install benchmarking, you may the basic or may not contain many function packages. So you have to add the packages as and when required. To do that, you have to download from some server. That is what you do is normally various mirrors would be available. You have to choose the mirror first time. First time in the sense whenever a session started, that time you have to choose the mirror. Then you install the packages. So I'm going for set mirror. Already I have, just I'm showing it for others benefit. So normally I choose France 2. That is a good one. That is the best as per my understanding. All the time, all the packages are getting updated. So you can choose something else, and whenever you have a difficulty, you can change the mirror. So now I've chosen the mirror. After choosing the mirror, I have to install the package called as benchmarking. There are not only one package does DEA. There is a package called as DEAR, capital R. There is a package. It works. FEAR, FEAR. That is also does DEA. A variety of packages available. So now it is up to us to choose the package because efficiency is same. So I'm not going to use anything other than benchmarking. I'll use this only. So after installing benchmarking, if you go here, I'll just show where it is. If you go install package, now the same window will appear. It is my net is slow. Yes, it's working. Yes, you can see this many packages are available. So I need benchmarking. So BENS. This is the package I want. I'm not going to install. Already I have. So look at the spelling. There are on benchmarking. B uppercase, M is small. Other things are small. Similarly, there is benchmark me data. So many things are available. You should know if you go to the help menu, if you ask what does this benchmarking, what are the functionality. Benchmarking documentation is almost 25 pages. If you download that PDF document, whatever the code I'm doing it, you can do it faster. To reach this level, I spent more than 6-7 months. I was working with the Excel. Then there are some open sources solvers by somebody I tried. There is something called as Leap, DEAP, variety of packages I used it. Then I realized this is everything is I'm unable to understand what expected result is not coming, why it's not happening. Then I analyzed R was when I did with manually, and then I found R is the best one. So I'm stick with R. I yet to explore the PIM package, DEA zone package, because it's costly for 50 first time 192 sterling pounds. Then every annual it is 15 sterling pounds for my updates and maintenance. So it's costly, so I'm not using it. So I'll just stop here. I'll go to after installing the package. What you have to do is require or library. That package within the package you have to put benchmarking. Okay, see I said uppercase. I'm not used that. If I not using it, it will say error benchmarking. So this has some dependency. LP solver, linear programming solver API, and UCMNIF. So what is required? All dependency download. Suppose you are installing it, that time also you can say dependency equal to true. Install dot packages within double quote, within open parenthesis and close parenthesis double quote, package name, comma dependency equal to true, you'll get the package. So then once you download it, require or download. Now if I use DEACRSN, I'll get the value. So now I did not type. So there is a GUI for this called as R Studio. Till you learn something in R, don't depend on R Studio. This is the best one. Please use this one. The moment I did some orientation, I said orientation will give some error. I'll modify it because it's a default values orientation is in. So I'll do this one. So now how to find the value of this histogram? I put efficiency scores I want. That is this one. The name of the values where we stored is CRSIN, and then I closed everything. I got this histogram DACRSN. So this is, suppose I want to find the value of efficiency. Okay, this I can close this one. I can go to just I want to know the values efficiency DACRSIN. Okay, EFF, what I used. Let me see. EFF DACRSIN. What I spelling is IN. Yes. What was the mistake in the last line and this? Okay. There are two braces I used it, therefore it not given the value. Now look at this. There is bank 2. That is Andhra Bank was efficient. If you look at that scale, you can find out this. This can be written back to the CSV file and you can do manipulation. So histogram is given this way. So suppose I want to do the same thing for super efficiency. I said super efficiency, when we use it, the value is not necessarily 1. It can go beyond that also. I just put E, SDA, XMAT, YMAT, RTS. If you remember, for all other models, I have to allow VRS scale. Now, efficiency of E, if I put, you are getting infinity and all. So that's what I said. The data is really suitable for super efficiency and other things. You have to work on that. So you look at this. This is the restriction is removed. 8 point something into minus. So this is not that possible. So 2 point is yes, 0 0 is there. 2.1, 1.2. So when don't want to, the efficiency can be anything, then obviously it is possible. So this is one way of doing it. Suppose you want to know that peers, we can put that peers of E. What is the meaning of this? For 12, the peers are, you have to compare the DMU2, that is Andhra Bank, 14, 19, and 26. Compare this with respect to make this also efficient one. So that way you can go for it. So something we can do directly, identify the slacks and everything in one line. So what you can do is you can define as a data frame, all you can put one line. So this is a way one can solve DA using R. But MATLAB does not have any functionality for DA as per my limited knowledge is concerned. We can solve LPP. One important observation before I stop minimize this one, the number of DMUs, the relationship between number of DMUs and number of inputs and output is very important in order to get right efficiency, or you believe that is correct. There is a paper which talks about the number of DMUs supposed to be more than 3 times of number of inputs plus outputs. For example, if you have 5 inputs and 2 outputs, your DMUs required is 21, at least 21 is required in order to get the proper way. So otherwise, we'll get some efficiency score, we may not have that. Okay, the important observation here is why can't I do regression analysis? We have seen that. Also, the basic assumptions of regression analysis, if you look at that, we supposed to be that data is supposed to follow the normal distribution and all such things. Here it is not possible. The same way, the other important frontier one is called a stochastic frontier. The stochastic frontier also we supposed to have the data is supposed to follow half normal distribution, all those things. So this all we eliminated. There is a nice book on SFA and DEA. So that is also one can refer. Now plenty of books are available. When I started, only 3 books. Now more than book. There is one book in the service industry by SC Ray. Then handbook of DEA. So I'll show some from the slide, good references, very important. I'll close this or I closed or. Yes, I closed or. I'll go back to my slide. Okay. So the limitations, as I said, what to include, what not to exclude. There are so many things. That's what I said. One can use the correlation analysis and do that. That is also not going to be give us the right input and output. One by one, you have to put one, find the correlation, remove it, add it, see that efficiencies. So dependencies, how to find out it is a unsolved problem even today. So if it is quadratic way, then we have to apply some linear way, linear as I said, then find out correlation. Yes, it is possible. This is another way of things. Now, sometime beyond this, something called as network DE analysis, two-stage DE analysis. That is three-stage. The two-stage DE analysis, not necessarily network DE analysis. So what is the meaning of that? First stage, I'll use the DEA model. I find efficiency scores. Then I go with a tau-bit regression analysis. So the tau-bit regression analysis, also a lot of statistical parameters are required. So it will satisfy all those things. Then you can do that. Or sometime after that, I can use it corrected ordinary least square method regression analysis. I can go for variety of things. And using DEA, you can classify that what I talked about as good performers, the nice performer, the niche ones, then poor performers, the worst performance. You can classify, you can create a like a SWOT window, you can create a nice window, you can analyze that also possible. So it is depending on that. There was a time I was thinking to apply this in the IT industry to identify this category. I got data, but some reasons I did not take it up further. The simplest reason is we are going to play with human lives. I don't want to give that kind of model to IT industry. You know that IT industry, how they are terminating people in the earlier occasion. You are a senior and they want to send you out, but you have a good name among your peers. They isolate you in a different way. Isolate in the sense, one is what we expect is you put on the bench, then subsequently you shown termination notice or something like that. But the nice way of doing is you promote to the next higher level, create a new team, and send you in with 3 months. So these are the things are happening in the industry. So in addition to that, I don't want to give this model to IT industry, so I did not do that. But I got data of more than 6,000 employees in a particular company, Indian-based company, Indian IT company, but I did not do it because of this reason. So these are the references. I said my book chapter is very simple. Anybody can read and do. That is the meaning I written this book chapter, which is published in 2019. It's a nice thing. There are 2 chapters I written. Please, if you can see something online. LPP I used in the different domains, how we can apply LPP. So you can see to study application problem from LPP or operation research, I suggest the second reference, Introduction to Management Science towards Decision Making. Anderson Sydney, 14th edition. Now it is 15th edition is available in the market. That's what I learned that. This is the real eye-opener for me, this 3. Greenberg, HJ, how to analyze result of linear programs. So part 1, part 2, part 3. This is probably you may get online. Unfortunately, I could not get online. I got it from other friends, but then I learned a lot of stuff how to do this kind of things. Okay, so this is again the convex analysis concern. Please look at this. As a mathematicians, we look at this Springer Science and Business Media. This is the place you are going to get a lot of things how it is applicable in the other discipline. So please refer. See in infinite dimension analysis. So same publishers. So 2015 and 2012, beautiful book. One thing I have to say here is in Western University economics, those who are doing PhD in economics, they know functional analysis far better than us. Unfortunate thing, but that's a fact. the kind of application they worked on, that we study theorem as theorem and we forget it where it is applicable, we don't know. But the blenders helps to understand and retain whatever they learned. So that's how we have to look at that. And certain places it's possible. Wherever I'm able to set up the syllabus, I put certain level of application. Books also I changed it. But the cooperation from our colleagues is slightly tough. But when I put forward, I'll help you this area, then they agreed upon that. It took some time, but constantly I'm unable to do with everywhere. It's okay, fine. I'm trying to do something. So this is a book I strongly recommend. W. Cooper is the man, first man, the CCR model, the first man. So this is Zhu is the other person. Every year, one data meta-analysis conference is happening, organized by Joseph Zhu. Also, last year, still that position is opening is there or not, I don't know. They were looking for 3 postdocs doing on data analysis. So funding is there. Recently, probably you are in Chennai, you know well, 2019 or 18 December, like that. Pondicherry, the first time in India, one conference happened on data analysis. Pondicherry University did that part. So all other places, data analysis may be a parallel session, but not in detail. National Productivity Council of America's conference, one parallel session totally on data analysis. So obviously, it is a nice discipline. If you are able to relate with mathematics, and we can put that, it's going to be a nice thing. So one more small assignment or whatever we call is just I'm thinking of loudly. API, we have Academic Performance Index. Because of again, thanks goes to I have to say sincere thanks to Venkatraman. After he discussed, I thought, why not I take API as a DA model and write a paper? I may be successful, I don't know, but I'm just throwing open for all of us. Just try. It's a good work. So API is used in many places. Obviously, we can design who is doing better. If there is a mechanism to find out, feed the data into the system, it throws he is far better or she is better. That's a nice way, instead of saying I have more points this and that. At least inside a department, you can identify who is performing better and identify what makes the person to perform better. We can learn from the other person. That's all I have. Sincerely thanking you, the organizer, as well as the participants to listening me so far. I'm open for questions now. If you have further questions or discussions, can be sent through mail. My mail ID is also I put here. So any mail you can send across. A maximum of week's time I can respond. Thank you so much.
Thank you. Sir, there is a question from audience.
Yeah, I'll stop sharing the screen. I can see that.
Sir, can you explain super efficiency model and Malthus model?
Super efficiency model and
Malthus model.
Malcolmist model. See, the Malcolmist model is a window data, time series data you're supposed to have. Then you can go for it. If you have a time series data of more than 15 years, then Malcolmist index also can be studied the efficiency scores. So for that, the coding is different. This is not the code. That's a place I sit. One can download the benchmarking package document. Download that. There is a given example. You can know how to do that. Super efficiency, where we talk about the efficiency can go beyond 1. That is the difference between general model and this. Otherwise, efficiency is assumed that between 0 and 1.
Okay, sir. So one more question is there, sir. Is there any software or freeware to measure DEA?
Ma'am, I started with the open source. The open source meaning is it's free. Freely to download. You can look at the source code, as well as you can build again additional models. That is what called as open source. So R is an open source to do DEA. There are certain DEA tools like DEAP, DEAP. That Problem with that is the efficiency score is not matching with manual value. One, the reason when I analyzed it requires MS Access 2010. Suppose you have an Office 2016 and your Access is also 2016. There is a conflict between these two. So open sources only R, I suggest. Nothing beyond that.
Okay, sir. Okay, sir. There is no matrix representations also connected to this theory, sir.
Ma'am, it is very clear. It's an LPP. LPP, what you do, if I say optimize sigma I equal to 1 to n ci xi, subject to ax, A is a matrix, x is a column vector, less than or equal to or greater than or equal to b. B is again a column vector. So any LPP is a matrix. So this also a matrix.
So one more question is there, sir.
Okay.
Parallel input
Now,
efficiency, parallel output efficiency, input orientation. No, sir. No,
okay, right. Yeah.
it's very clearly understood, sir. Okay, sir. Session is very clear and effective, sir.
Okay.
Yes, sir. Thank you, sir, for your enlightening lecture.
Thank you so much, ma'am. Yeah. Can I sign off, ma'am?
Before we move on to our formal vote of thanks, I would like to inform about our next webinar, which is a workshop on GeoGebra, a teaching tool which is freely downloadable on 12, 13, 14 August 2020 between 10 a.m. and 12:30 p.m. This tool will be of great helpful, especially to the school teachers and school students to understand the images of curves for various functions. It will enable us to have better understanding of the nature and structure of curve under study. Gratitude is not only the greatest of virtues, but the parent of all others. Now, Mr. Somasundara Ori, Assistant Professor, Department of Mathematics, D.G. Vaishnav College, will propose the vote of thanks.
Good afternoon, all. On behalf of DG Vaishnava College, PG and Research Department of Mathematics, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this webinar on applications of linear programming in performance measurement organized by our institute. At the outset, I thank respected and our most distinguished chief guest and resource person of the day, Dr. Ka Venkatesh, Adjunct Professor, Indian Institute of Information Technology, Bangalore, and Professor Mathematics and Computer Science, Myanmar Institute of Information Technology, Mandalay, Myanmar. We are really enlightened with your knowledge and presence, sir. I thank you for your excellent presentations and making this webinar more interesting and meaningful. We are thankful to our beloved secretary, Sri Ashok Kumar Mundraji, for his motivation. I would like to thank our respected principal, Dr. R. Ganeshan, for his enthusiastic support. I would also thank our beloved head of the department, Professor R. Venkatramanan, for organizing this webinar series. His wish to kindle the spirit of mathematical idea of young minds, researchers, and faculties of all institutions throughout the country. A special thanks to the organizing committee, faculties of our department for their unflinching support and coordination. Our heartfelt thanks to all participants. With these warm words and a kind message, we move to the end of today's webinar. Thank you.